Welcome back to S1 Geography Week 2. This week we are going to be looking at tectonic plates. So last week we looked at the four key parts of the Earth's structure, and the one on the top was the Earth's crust. Now the Earth's crust is made up of a number of these plates called tectonic plates. And these plates are always constantly moving, just very slowly, so you'll never actually feel it or see it. They move because the mantle underneath is always flowing. So, because they sit just on top of the mantle, they're floating on it, the flow of the mantle causes them to move in different directions. So the Earth used to be one big supercontinent called Pangea. Now, over millions of years, Pangea broke apart and large pieces of land slowly move away to form the continents as we know them today. These continents are all sitting on top of different plates. And because the plates move, the continents on top then move apart as well. So how did we find this out? Well, reason number one, the different continents fit together like a jigsaw, so we can see where they previously would have joined together. Reason number two, fossils of the same dinosaurs have been found on two completely different continents. So the same fossils were found in South America and in Africa, which are both really far apart now. So it gives you the idea that these continents were a lot closer so that animals could have just walked between them. And reason three, we have found the same rocks and soil on two completely different continents. So these were probably once joined together and then they split up and move miles and miles apart due to the movement of tectonic plates. Last week we learned that the mantle moves due to convection currents. This causes these tectonic plates floating on the mantle to move. If they move in certain ways, this can cause volcanoes and earthquakes. There are four different types of plate movements that we're going to learn about. The first one is destructive plate boundaries, then constructive plate boundaries, conservative plate boundaries, and collision plate boundaries. The first one is a destructive plate boundary. This is when a plate which is sat with water on top of it moves into a plate which is a continental plate. The water plate is forced underneath the continental one. This causes a lot of friction, which may trigger an earthquake, but it also pushes magma up through cracks and through volcanoes on the surface of the Earth. Next, we have a constructive plate boundary. So constructive plate boundaries occur when plates move apart because new land can form through the magma filling up in the middle. This also can cause volcanoes. So it's a constructive plate because they move apart. New land is constructed by the magma which comes up and hardens on the crust surface. Next, we have conservative plate boundaries. A conservative plate boundary occurs where plates slide past each other in opposite directions, or in the same direction but at different speeds. This causes a lot of friction and eventually it is overcome and the plates slip past in a sudden movement. The shock waves create an earthquake. And lastly, we have collision plate boundaries. This is when two plates hit into each other. Neither plate is forced underneath the other, so they go up instead and they form fold mountains.